Okay, I'm sharing my screen. Let me know when you can see it. Okay, so this is the schedule for the day. So we will start stack, then few basic theory and implementation of stacks. Then we will solve few problem solvings where stack concept can be used. Okay, so before that, let's see what is a stack. So till now we have seen linear data structures such as arrays and linked lists. So arrays 1, 2, 3, 5, 6. Okay, if not linked list. 1, 2, 3, 4, 5. Okay, so these two are fine. These two works fine. These two grows linearly. This is static, and this is arrays is static, and this is dynamic. So that's our difference. And insertion can happen in whatever place we want. So I can add some element here. So I can add some 7 here. Okay. So in arrays, randomly we can do. So arrays, or it will be order of 1. But linked list also we can do. We can add something here, and we can point it here. So again, insertion can be happen anywhere, but the time complexity differs where you want to insert or not. So that's the thing. So, but stack is a special kind of operation where stack is a special kind of data structure where uh, it's a dynamically growing linear data structure, first of all. Second of all, it is having some restrictions while in insertion and deletion. So the restriction is that the insertion and deletion should happen both at the same end. That means insertion should happen at here, this end, and deletion should happen at this end. So by maintaining these two property, we come to a data structure which has which follow this thing. So last in, first out. So if you follow these two properties, that means insertion and deletion both at same end, we get a sequence of last in, first out. That means whatever element I insert at the last will be removed first. Okay, so basically stack is a data structure to store elements in last in, first out order, something like this. So practical usage, think of it as a book stack where if you have 10 books, the first book that you put the first book that you keep in the table will be the last one to be removed from the table. The same way this is there. So the first element or the first data that is inserted into stack will be the last element to be removed. So it is also having many use cases, guys. So the best use case could be the call stack. So whenever I'm calling a function and I'm going into recursion, these functions are stored in my call stack. So let's say 1, 2, 3. Okay, so these functions are nothing but they are stored in the call stack. So 1 will be stored, 2 will be stored, and then 3 will be stored. And 2 will be only executed once 3 is completed. So we all know that is how recursion works. So once this is done, once 3 is completed, then we will go back to 2. So this is how call stack is working internally. They maintain a stack where the execution context is stored. So 3 will be executed completely, and then it will be removed, and then 2 will be executed. So that is one example. The other example could be browser history navigation, many things. So these are the web pages, let's say. So you visit a.com, from there you would visit b.com, then c.com, okay, so on. So these are the history. So when you click back, in this order you will go. So kind of an example of stack. So basically stack is a DS which maintains data in a way that the last inserted data is the one that is removed first, and the first inserted data is the one that is removed last. So last in, first out, or first in, last out. Both of them are same. First in, last out. And why do we take this much of efforts to create stack? Because stack is having many applications. So call stack is one among them. And depending on the problem, we can have it. So if you see, as we are doing both insertion and deletion at single end, so our time complexity should be always order of 1. So insertion and deletion in stack is order of 1. Any questions till now? Okay. So now the point is, how do we implement a stack? So for arrays, this thing compiler or the language itself provides us some array square brackets like this, so we can use it to create an array. Linked list, we create a class and then we manually link the nodes. But how do we create a stack? So what is the procedure to create a stack? Can someone put in the chat, how do we create a stack, or how do we implement a stack? How do we implement a stack? Come on, guys, be responsive. Why is no one replying? So stack implementation is simple, guys. As we know the array and linked list. As we know array and linked list, we can implement a stack using both arrays or linked list. So first, let's see how do we implement using arrays. So we maintain a index, and we will do insertion and deletion using that index only. So let's say we initialize a stack like this. Okay, so with some size. So this is the first index. That means the insertion and deletion should happen at this end. So is there any value to be deleted? No. So in this case, when the stack is empty and you're trying to delete a value, that is known as stack underflow. Stack underflow. Underflow. Okay, when you're trying to delete an element from the empty stack. So, and when you're trying to insert an element to a full stack, that means my index is here. That means I cannot add more than any of the elements. So in that case, my stack will be uh, overflow. So these are the two edge cases of stack. So as a stack is if you are implementing using arrays, so arrays is static, that means the size is fixed, and once the size is fixed, then these two conditions may arrive. Okay, so we maintain an index. So let's say I'm inserting 1, 2, 3, 4. So the first index I will add 1, then I'll increment this 2, then I'll increment this 3, then I'll increment this 4. Okay, so once this is done, whenever I'm popping out, I'll just pop up with those elements only. So 4 means 4 will come out, and this pointer will decrease. Okay, so whenever this pointer is decreasing, basically this logically means that this entire part is not at present in the stack. Okay, so with this kind of a pointer, we maintain a stack using arrays. So it's a very simple implementation. If not, if you want to implement using linked list, tell me insertion and deletion should be at same end. So which end should we use? So we have a head pointer which is pointing to null. How do we implement using a linked list? Tell me. Come on guys, insertion and deletion should be at the head or should be at the tail? So both should either happen at head or both should either happen at tail. So it is up to us. But the important point is it should happen on only one end, either head or either tail. So let's maintain head as the pointer. So first one is added. So one is pointing here. Then two will be added, right? So insertion at head. Then three will be added. Two and then one. Okay, so like this. And whenever we are deleting, so three will be gone and the head will point to two. So in that way, we can create a stack using linked list. So both of them are simple implementation. This is the restriction with arrays is that the size is fixed. So we have to know the size. So we have to give him a static size of, so let's say 100 or 200, and we cannot store more than 100 elements in the stack. Okay, so in this condition, we will get a stack underflow or overflow. Whereas linked list, these are dynamic, right? So we can have any number of elements in the stack. All we have to maintain is this property of insertion and deletion. Insertion and deletion should both happen at same end. So complexity wise, as you know, so arrays, no doubt it is order of one only. And even in the stacks, so as we are doing insertion deletion both at the same end, so it will be order of one for both case, insertion, comma, deletion. Both will be order of one. And then you know the applications of course stacks. So stacks are having multiple applications. So call stack. Okay. Okay. Yeah. Let's see the implementation part. Then we'll move on to the problem solving. Okay, let's first do it with arrays. So I will have something like this. Class my stack. Okay. So in here we will maintain a array. And okay, yeah. So one important thing is that insertion and deletion in stack is known as push pop. So these are the terminologies: push, pop. This is nothing but insertion. This is nothing but deletion. And there is one more special method called peek. It will return as the top value of the stack without removing it. So if you just want to check the top value, we can use peek. So any stack that you are implementing should have these three APIs written: push, pop, and peek. Let me create a stack. And then in the constructor, I will get the size of the stack and then I will initialize it. It is done. Now we will also maintain indexes. So I'm initializing it to -1 to represent that the stack is empty. And before insertion or deletion, I will just increment it. Okay, so now let's do a push pop operation. So before insertion, I have to check whether my stack is going overflow or not. So in that case, I will just check whether my index is equal to stack dot length -1 or not. That means it is already pointing to the last index of the array. So in this case, I cannot add any of the elements. So I will just say, I'll just throw an error. Stack Overflow. So else in that case, so now I have an element or I have a place to store. So I will just use the increment operator, pre-increment, because it is starting from -1. So it should be incremented first. That's it. Okay, so this will push my element into the stack. So now let's do pop. Public int pop. So even here I should check whether my index is equal to -1 or not. So in this case, if it is -1, that means the array is empty. So in this case also I have to throw a new error. Stack underflow. And if not, I will just have to return the value. Return stack of I minus minus. So why I am doing minus minus here is in here it will first return the stack of I, that is the last value, and then it will decrement it. That's why post decrement. So this is pre-increment, this is post decrement. So pre and post, remember the differences between pre and post. So now if I want to just peek public int peek, again even here I have to push the same logic, but before here I am doing decrementation. That means I am logically removing the this is index, logically removing the element from the array, but instead I should be only seeing the element, so no decrement. Yeah, so this is done. Okay, let's say I just want to print it. So public void I'll just say system. So as I'm using arrays to implement stack, I'm just printing that array. So I can just okay, so this is done. So now I want to execute it. So first of all, I will take the inputs from the user. So 4, 1, 2, 3, 4. Int n is equal to next int my. So now I'm creating the stack object, and then I'm passing him the size. So let's not take user inputs from user. So let's do it in our own way. So let's give him a size of 5. Then stack dot push 1, then push 2, then 3, then 4. Okay, so then I'll just print it. Then I'll pop it. So before popping, I will just print out the value. Oh, I will also check peak. Yeah, so let's test it. So yeah, so this should work, and we have implemented a stack using arrays. Okay, so if you see 1, 2, 3, 4, and this is the last. So my last elements are not filled. If you see, Whereas even if I'm popping out my array, the 4 is still there in the array. So I'm not removing that index or removing that value. But I will not be in a position to access it. So that's the point here. That's the reason why we are maintaining index. Though we are having that value in memory, but we are not accessing it. Okay. So peak is 3 and then pop is 3. So once I remove, then this is the value 2. So if I push it, then if you notice this, then you will understand. See this now. So I have removed 2, 3, and then I am inserting 4. So in this case, if you see, 4 is getting inserted, and then I'm printing it. That means 3 is replaced by 4. So this is the part where my top of the stack is now. Okay, so let's try to get stack underflow condition. So there are 3 elements. 3 will be removed, and the 4th one will give us a problem. So see this stack underflow. That means we are trying to remove all the element which is not present in the stack. That's why it is stack underflow. At the same time, if we do push elements some more number of times, then if you see this is 4 is inserted, right? So let's try to insert a few more. So till 5 we can insert because it is valid, but the 6th one will give a stack overflow. See, stack overflow. Okay, so this is the stack implementation. Just go through it once. Any questions, guys, in this implementation? It's a very simple implementation. The order of 1, order of 1, order of 1. Any doubts? Let me know in the chat. Okay, so we will quickly see the linked list implementation as well. Okay, so let's move ahead. So I will implement a node. So basically for linked list, I need a node, right? Node int data node next. This is public is not required, but still I'm writing it. Now public node start data is equal to data start next is equal to next. Sorry, null. Okay. Just give me 1 minute. Okay, so this is done. So my node class is done. Let's say I create a new class now. My stack list. Let me write it like this. So it's the first thing that I will have is a head pointer. Head. Okay, so no need of constructor because it will be empty by default. So the directly we will implement push and pop. So public void push int data. So firstly I have to create a new node. So node. So insertion at head, this is new node is equal to new node of data. So insertion at head, the head pointer will always change. So we will be doing new node of next is equal to head. This dot head is equal to new node. Head is equal to new node. That's it. Okay, so this is push is done. So now similar way pop int. Okay, so firstly I have to check here because there is a condition of underflow. So dynamically growing stack can have underflow but not overflow because overflow will not occur as it is growing dynamically, but underflow can occur. That means the stack is empty and then I'm trying to remove it. So first I'll check if my head is equal to null and throw new error. Underflow. Okay, so underflow is taken care of. Then I have to return the value. So int data is equal to head dot data. Head is equal to head of next. Return data. Okay, the same thing goes to pop. Sorry, peak. But in this case, we just return the data. We don't change the pointers. Yeah. So this is all about uh, push, pop, and peak. So if I just change it to this thing, the output should be exactly similar. But only one thing is that it will not have the stack overflow condition. So print was not there. So let's implement it. System.out.print. Okay. Cannot be applied to given tag. Okay. So the size is not required here. 5, 4, 3, 2, 1. 5 is popped, then 4, 3, 2, 1. 4 is popped. Peak is 4. Pop is also 4. Then 3, 2, 1. And then when I insert 4, 4, 3, 2, 1. Okay. So in here, the elements are removed. Okay. So they are not maintained in the list. The garbage collector will do the job and it will remove it from the memory as well. So in linked list, but whereas in arrays, they will be there in the arrays but will not be accessible. Okay, clear everyone with this thing? Come on guys, be responsive. So I'm sharing these two implementations. So Java also has some stack implementation. So if you see this, So Java internally has a stack implementation, so we will also go through that. See, stack is a class in Java, and that means we can create a stack, and it has three methods: push, pop, and peek. So we can also use Java stack method. So if I just change it to stack, okay, so it will be the exact same thing. Stack doesn't have print method, so I will just remove it for time being. Okay. So it is maintaining the same thing, guys. So internally it is having the same thing. So if you want to see the stack value, I'll just say stack to string 1, 2, 3, 4. That means what? 4 is the last value here. Okay, so insertion and deletion are happening at this end. So you will easily get it. So if I just place it here. So 1, 2, 3, 4, 5, then pop 5, then 5 is gone, and then 4, 4. So then 4 is gone, and then 4 is added again. So if you see, the elements are removed. So where did we see this kind of behavior? So where the element is actually removed? Tell me in the chat. Where did we see just now in these two implementation? Where did we see that the elements are actually removed? Come on, guys. Did we see it in linked list implementation, or did we see it in array link implementation? Tell me that. Okay, so guys, so no one is replying, but two members replied. Yeah, so we have seen this kind of implementation in linked list. So in linked list, the actual value is removed. So how did Java remove the actual value? If you go to the documentation, you'll understand. So it is using vectors. Vectors is nothing but a linked list, so dynamically growing linked list. So implements a growable arrays of objects. See, growable arrays of objects. So just go through this definition, you will understand. So it is also kind of a linked list only where the dynamic it is growing dynamically. So that's why the elements are removed dynamically. Okay, so we can either use the Java's inbuilt feature, inbuilt stack, or we can create our own stack. So that's the part. I will share this code so that you can go through it. Yeah. So let me share the first one. Second one. Third one. So if you have any doubts, guys, please let me know. Don't be this silent. Just take a note of these programs, and then we will start with the arrays problem solving questions. Peek is a method to just see the top of the stack. So pop will remove the top of the stack. So if you just want to check what is at the top of the stack, then we will use peek method. Any further questions? Okay, so let's go ahead with the problem solving questions. So the first and the standard one is the balance parenthesis question. So the question is, you are given a string. So you're given a string that consists either opening brackets or closing brackets. So it can be like this, it can be like this. So it can be also like this. So if you see, this is a balanced parenthesis because all the opening is having a matching closing parenthesis. So this is closed, and this entire thing is closed. But this is not a valid thing. So given such string, you have to check whether it is a balanced parenthesis or not. So how will you do it? What is your approach? Did you get the question, everyone? Given a string containing opening and closing brackets, you have to check whether the string is balanced or not. Balanced is nothing but a string which is having proper opening and proper closing. What is your approach, guys? We can check using the ASCII value of the total string. Okay, how will you check? So yeah, ASCII value you can check, but how will you determine whether it is a balanced string or not? So for one opening, you have to also check for the appropriate closing. So let's say this is the string given to you. This, and then this. Okay. In this case, this entire thing is balanced, but when you consider the entire string, this is not balanced because there is no closing for it. Yeah. So the first thing you can do is you can just count the number of opening and number of closing. If you see here, the number of closings are more. Sorry, number of openings are less. So in this case, that will help you to solve the problem. But that counting will fail in this approach. You see, here the number of closings are two, number of openings are two. So both are same, but they are not valid here. So this counting approach will not work. There is one more approach where we can use stack. So the basic thing is, so if that is the case, so whenever we see an opening bracket, we push it in the stack. So opening, opening, opening. And then whenever we see a closing bracket, we try to pop it from the stack. So for any closing, if there is no proper opening, that means it is invalid. And at the end of the array, if there is any opening left, that means that is also not a valid string, a valid parenthesis. Okay, so we can use these two approaches. The first approach will not work for all the conditions because counting is not reliable, whereas stack will work for all the approaches. So let's see that. Yes, we can do that, and I will explain you in a bit, Shrikar. And he will give us a string. Okay. So first thing first, we have to traverse through all the elements of int I. So we will create a stack. I'm going with the Java inbuilt stack. Okay, so the stack is created. Then for int I is equal to 0, I less than str dot length stack dot. So firstly, I have to check if if it is an opening bracket. Then I have to push it in the stack. Okay, else we have to remove it. So before removing, there are a few conditions I have to check. If my stack is empty, that means I am trying to remove, but my stack is empty, then this is not a valid string. That means return false. Else then I will remove it. So stack dot pop. Okay, so this will continue for all the cases, and at the very end, I have to check whether my stack is empty or not. So if the stack is empty means all my opening and closing are removed. So this means it is valid. So if why this is important, because at the end there might be case that we are left with few opening brackets. Consider this case, something like this. So in this case we are left with two opening brackets. So we have to check that one as well. So that if stack is empty or not. And let's test this. So let me give a string which is balanced. So this str dot caret is not present, is it? What's the method here? Char coded, is it? What is it? It is there, right? String dot caret. Okay, we have to pass in the index. Sorry. Yeah, so this is true. So yeah, this is true. If not, we can, if it is something like this. So in this case, this is not true. So in this case, there are two opening brackets. So this is false. At the same time, if there are two closing brackets also, it is false. Yeah. There is one more sanity check you can do is if my str.length percentile 2 is equal to 1. That means if it is odd, then return false by default because a balanced string will always be even number. So this is done, and yeah, so everyone got this solution. Why did we use stack? Okay, so if you see the time complexity of this logic is order of n, it is trying to go through the length of the string, where n is the length of the string, and the time space complexity is also order of n because we are storing a stack. So is there a better way to do it? So if you remember, I'll just share this code now before I change it. So if you remember, there was a counting approach. So we can use the same counting approach, but before trying to decrement it, we will check whether the opening bracket is there or not. So we can just maintain a count like this. Count is equal to 0. Stack is not required. So if my this is opening bracket, I will just say count plus plus. Okay, and before and here, so before checking, I'll just check if my count is 0. That means there are no opening brackets now. If not, I'll just say count minus minus. And I will just check here whether count is equal to 0 or not. Simple. So this approach will also work and it will give us a correct answer. So that space complexity here is reduced to order of 1. So that's the trick here. But the disadvantage of this approach is that what if my string is too big? So what if the count, if you remember, count is nothing but an integer. So integer is nothing but a range of number. So the maximum number it can hold, let's say 65,000. But if my string is more than 65,000 characters, then it will break. So that's a disadvantage. But that's a very rare scenario. You can just look into the constants, problem statement constants, and decide whether to use this approach or not. Okay, so did you get this count approach? It is false. It is true. Okay, so this is also the same thing. Let's go through this logic once and let me know if you have any issues. So both of them are fine. Stack is a standard way. Always people first think of stack, but if you don't want to use stack, this is a second approach where the space complexity is order of 1. We go through the logic once. If the count value is equal to 0, why are we decreasing the value? We are not decreasing the value. If the count is equal to 0, we are returning false. That means there is a closing bracket, but there is no opening bracket. So count is nothing but the count of the opening brackets. So there is a closing bracket we have found, but count is 0. That means opening bracket. There are no opening bracket. That's invalid. So we are returning false. If this is not the case, that means there is an opening bracket. That's why we are returning. We are doing count minus minus. So every opening bracket, we are count plus plus. Every closing bracket, we count minus minus. At the very end, if the count is equal to 0, that means my opening and closing are balanced. I hope I answered you. Any further questions? It's a very simple logic, guys. So explain again means, see, count we are just, so we use stack, right? So stack is nothing but we are just maintaining opening brackets. Whenever we are seeing opening brackets, we are popping it out. So why to just use a stack just to maintain opening brackets? We can maintain count. So if you see, there is no different value in this stack. We are just maintaining opening brackets. So why can't we just maintain count? So this is 3. That means 3 opening brackets are there. Then 2. This is 1. So if you see, this is the sum of the, or the length of the stack. The same way we are maintaining just the count. So the whenever I see an opening bracket, I increment the count. And whenever I see a closing bracket, this is the part where I have to decrement the count. So before decrementing, I have to check whether there is an opening bracket or not. This is what I'm doing. If the count is equal to 0, that means there are no opening bracket. I'm returning false. Else I'm just decrementing. So after this entire for loop, if my stack is empty, that we have seen in the other solution, other approach. The same way we have to check whether count is equal to 0 or not. Okay. So now the next question is a similar question, but there is a few different things. So now the string can have multiple types of brackets. So it can have like this, it can have like this. So now you have to check whether this is balanced or not. So if you see, this is balanced because all the elements are properly enclosing each other. But if you see this is not balanced. And let's say this is not balanced. Okay, so again the same, this can also be not balanced. This is not balanced. So this is the approach question now. So given a string of multiple types of mm, uh, parameters, not parameters, multiple types of brackets. So now you have to find out whether that string is a balanced string or not. So what is the approach? How will you do it? Let me know in the chat. Come on, guys, think. So if I just come here, explain you a few problems and I leave, so nothing will change. So you have to think on your own. Just like the previous one, but the main thing is to combine the count and also maintain the ASCII. Yeah. So it is very similar to the previous question, guys. So only thing we have to do is we have to be conscious about the opening type. So previously we were just removing it. You see, we were just incrementing the count, but now we have to be conscious about the what type of operator or what type of bracket it is. So let's revert back to the stack approach. So stack character, new stack Okay, so if this is an opening bracket, if this is, let me write it like this. Okay, if my CH, that means my character is any of the opening bracket, I have to push it. Or if my CH is equal to, or if my CH is equal to, okay, in this case I have to push stack dot push the CH, stack dot push the character. So now before removing also we have to first check. So I will just check if my stack is empty. So this is the basic condition. If my stack is empty, return false. Okay. Else what? Else we have to remove the element. So I will just say the char top is equal to stack dot pop. So now I have to check whatever I removed is it correct or not. So if my ch is equal to this thing, that means this is the opening one. Sorry, this is the that means this is the closing one. But and my top is not equal to this thing, then return false. Just try to understand this logic. So I'm saying that if my the bracket that I got, or I'll just maintain in reverse order so it's easy for you to understand. So if my top is this thing, that means if it is not this, let me reverse it back. Easier to explain here. So the character that I'm present is the closing bracket of this thing, but the top is not the opening bracket of this thing. That means it is false. That is, it is not a correct case. So we can do it like this. Okay, the same goes to the three different things. So the character that I am here is the closing bracket of square brackets, but the top is opening. If it is not the opening of this thing, then return false. Similarly, this thing and this thing. And at the very end, again, the stack dot empty. So see, true. So I can give some different. So this is false. This is not correct. This is true. Yeah. So everything is working fine. So as expected. So based on the brackets, we have to decide now. We were just previously we were just removing it, but now after removing or before removing also you have to check. So instead of this thing, you can use peek also if you don't want to pop it before. Okay, clear everyone with the stack approach. So if you want to use a count approach, you have to use the same thing with three variables. So a count of circular bracket or something like that. You have to maintain the count of these different types of brackets we have. So something like this. So circular, you can maintain count 1, count 2, count 3. Count 1, count 2, count 3. So again, understand what is 1, 2, and 3. 1 you can fix it to this thing, 2 can to this thing, and 3 can this thing. So depending on this thing, you can do it. Again, the space complexity will be order of 1. So I explained you the stack approach. Try it out on the counting approach. So any questions, guys? Any confusion in this solution? So all we are doing is that whenever we are seeing opening, we are pushing it in the stack. This is the common thing. But whenever there is a closing, first we are checking whether there is an opening or not. First of all, that is the first check. If there is an opening, is it the correct opening? So how do I check? Whatever is the value, if it is not, if it is a corresponding opening or not. So that is that check we do. If this condition fails, we return false. Okay, let's move ahead then. I'm sharing the logic so that you can go through it later. This is a standard question, guys, in stack. So you all should know this. Okay, so now the next question is stack reversal. How do you do the stack reversal? Basically, you have a stack, you have to reverse it. So we know array reversal, we know string reversal, linked list reversal, but what about stack reversal? So this is a stack. So we have to reverse it 1, 2, 3, 4, 5. So after reversal, my stack should become 5, 4, 3, 2, 1, and this is in place reversal. That means my original array is getting changed. So how do you reverse a stack? Come on, think. Come on, guys, think. How do you reverse a stack? What will you do? So the two operations that is allowed is push and peek, push, pop, and peek. These are the three operations. So you have to do it in place. That means I am not worried about the process that you do in middle. So you can create your extra memory or whatever you want. But the thing is, this stack should be reversed. So 1 should be reversed and it should be at the top, and 5 should be reversed and it should be at the bottom. So in middle, for now, I am giving you the liberty of using anything that you want. You can use a extra memory or whatever you want, but I want my stack to be reversed for now. Pop followed by push. How can that work? So I popped 5. Then if I push 5, 5 will be the top. I will never get an access to 4. Maintain another stack elements from the actual stack and push it to the other. Okay, so in that case, if you see the one approach that was mentioned, so we have a stack like this. So what was the element? 1, 2, 3, 4, 5, right? So 1, 2, 3, 4, 5. So the approach was we maintain another stack and we push all the elements. So if we push all the elements, 5, 4, 3, 2, 1. But the moment I push all the elements, this stack will get removed. So this 5 will be removed, 4 will be removed, 3, 2, and 1. So this is empty. So now I want this thing to have a reverse thing. So how will I do it? I cannot change the memory address because it is in place reversal. So if I again pop these elements and push it here, it will again be 1, 2, 3, 4, 5. So that should not work. So maintaining a separate stack will not help here. Come on, guys, think. So think in a larger picture. So think whether if you can use a array to store the elements in middle, or if you can use a queue if you know what queue is. So think in those terms. Yeah, so the brute force or the approach here is that you should not put it in stack, instead put it in queue. So queue is a special type of data structure that we will discuss in the coming session, but just to give a hint, queue is first in, first out. Okay, whereas queue is first in, first out, stack is first in, last out. So if I put them in queue, this will be the order 5, 4, 3, 2, 1, and this will be the deletion order. The insertion will happen from here. So once I fill this queue, my stack is empty, then again I'll pop the elements and push it here. So it will be 5, 4, 3, 2, 1. Okay, that's how we can do it. So to reverse a stack, we have to use queue. Okay, to reverse a queue, we have to use stack. Now that's the basic idea behind it. Okay, so this is the thing. If not, you can just store it in array and comment from the reverse. So if you don't know queue, the other approach would be just store the elements in an array. So 5, 4, 3, 2, 1. So this you can do. But the point here is we don't know how many elements in it. So we cannot create an array without knowing the size of the array. So that's why we chose queues, because queue is also dynamically growing data structure. But let's say you know the size. Okay, you know the size. So Java will give you the size, but let's say the custom stack doesn't give you size. So we created a stack of size, and then we pop the element. So 5, 4, 3, 2, 1. And when I am pushing, I will traverse from the reverse. So 1, 2, 3, 4, 5. So that is one way of reversing the stack. So in this case, so we are doing it in place. But what if I want to return return a reversed stack without affecting the original stack? So how will I do that? So the point here is, so this is in place. So in place means this is the input. I am putting it into a queue. Then I am getting the input as reversed. So this is reversed. But here I want to do no input, no in place. That means I will be giving you an input. I should get an output of reverse stack. But my input should be intact. Input should be the exact same thing. There should be no change in my input. So if it is 1, 2, 3, 4, my input should be 1, 2, 3, 4 only after the traversal. That means after my logic. So logic. So this logic should be this thing. So 4, 3, 2, 1. And then 4, 1, 2, 3, 4. So this should be reversed. I should get a reverse stack, and then the original input should not change. So what do I mean by that is this thing, let's say public static stack reverse stack input. Okay, so you have to return a stack. You're getting the question, right? Did everyone get the question? So you are given an input. So this input you can use and you can do whatever you want, but after the logic, this input should not change. This input should be same, and you have to return a reverse stack. So how will you do it? This one we have seen. So if you want to do it in place, we will just put it in the queue, and from the queue we will again change the input. So it will be reversing in order. That means in place reversal. But I don't want to do in place reversal. Instead, I want to return the reverse stack. So what is the approach? Try answering them in the chat. So the first one, the first approach that is in the chat is that I will scroll down a bit. Okay, let me copy it. Okay, so this is the thing. So the first approach we can think of is, why don't we use a stack? Simple. So the first approach is this. So this is input 1, 2, 1, 2, 3. Okay, so on. So we will just keep a output array. So output, if I just push pop all the elements, it will become 3, 2, 1. But the problem here is, once I pop all the elements, my input will be empty. Input will be empty. So again, if I just pop it, my output will be empty. So in that case, what do we do? Be mature, guys. This is not a question of printing the values. This is a question of returning the values. So just come out of that mindset that you have to just print the values and that is done. So you have to return the element, you have to return the answer. It is not just printing the value in the reverse. So did you get this logic? So in this one, if you see, we will just pop the element. So output is done, but my input is empty. So for that, we can simply avoid this case by using some modification. So this is my input, 1, 2, 3, and this is 1. So let's say input array. So we will maintain two arrays, so two stacks. So I pop it from here and insert it here, 3, 3, and then 2, 1, and then 2, 1. So this is my output. 1 is my output, 1 is my temporary. So again, from temporary, I will fill my input array. So again, it will become 1, 2, 3. So input. So this way I can do it. So output is the reversed stack and input is my original stack. So this way I can do it. But the space complexity, if you see, it is order of 2n. That means I am doubling my space. Nothing but order of n only. Then I am maintaining two stacks. So can we do it in other way? So the other way is little tricky. So if you don't want to maintain two stacks in iterative approach, we can use the help of recursion. So we can go, so this is stack, right? So this is the 1, 2, and then 3. So we'll start our recursion with the top of the stack. So 3. So we'll pop it out. So pop and push the element. So this is my output. Output, I'll push 3. Then I'll go to 2. I'll push 2. Then I'll go to 1. I'll push 1. Okay, so by this time my input is empty now. These 3 are gone. So when I'm going back in reverse recursion, I'll just push all the elements. So what is the first element that will be pushed? 1. So again, if you push 2, then again if you push 3. So in this case, I'll maintain my stack, original stack in place. So as we have just seen that recursion is also using stacks, that means this is not a different approach than this one. So even here the two stacks are done. So instead of temp, we are using call stack. That's the only difference. So instead of one, we are only using call stack. This is a smart move. So this call stack method, interviewer may not force you to change or force you to update. So you can use this thing. Okay. So that's a solution. Let's see how we can do it. So we can have a helper function, public void logic input output. Okay, so I'll create a stack, the reverse stack. New stack of this thing. So firstly, I will just check if my input is null or not. If my input is equal to null, return null. Else I will call my logic. I'll say you take my input and you take my output, and you take my reverse. So once I perform the logic means you have to fill this array and then you have to return reverse. Okay, done. So first I'll explain you the code, don't worry. So int stack dot push int dot next int. Okay, so now my stack is pushed. So now what I will do is I will first of all I will print my stack. Stack dot toString. Okay, so now I will just say that I'm reversing. Reversing the stack. So okay, so in here I will use this reverse method. Solution dot reverse stack. Okay, so I'm just printing the reverse stack in string, and then I'm also printing the original one. So basically this first println and the last println should be same, and the middle one should be reversed. So if you just see, for now let's just return the input. The input will fail. Okay, so 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5. So this is not reversed, so we have to reverse this. So the logic is something like this. So yeah, so we will just create, I'm just creating a reversed array, a reverse stack, and then I'm calling my logic. So my intention of calling logic is that I give him the input and output, he fills the input and output and he gives to me. So first things first, if my input is empty, return. Okay, else int value is equal to input dot pop. So when I'm in popping out from input, I have to push it to the output. Output dot push value. So this will push it, and then I'll start my recursion. So in this case, so if you notice at this step, my first element is removed and first element is inserted. So this length is decreased and this length is increased. So then I will again call the same logic. So input logic of input and output. Okay, once it is done, that means when I am coming out of recursion, then I will push it again. So input dot push value. Yeah, see 1 2 3 4 5 5 4 3 2 1 and then 1 2 3 4 5. So the stack is reversed. So everyone go this approach. Let me explain you here. So the first thing that I am doing is, let's say this is my input and this is my output. So it is 1 2 3. Okay, by default I am starting my recursion. So the first step what I am doing in recursion is, see this. I'm popping out the value. That means I'm storing the value somewhere. Okay, let's say 3 is the value. Then I'm pushing 3 into value. So 3 is pushed. And when I'm removing, this is gone, right? So this is gone. So then I'm doing what? Then I'm going into recursion again. Then I'm going into recursion. In this case, again, I'm taking the value. So 2 is pushed here again. And then again, 1 is pushed here again. And then when I'm going here, so this is the part where input will be empty, because if you see 1 is 2 is removed, 3 is removed. So input will be empty. So now I will go back. So while coming back, what is the last step that is pending? Input dot push value. So what is the value here? 1. So 1 will be pushed here. Okay, 1 will be pushed. Then I'll be done with this function, and I'll be returning to the calling function. Then 2 will be pushed here, and then 3 will be pushed here. So if you see, my input array has come to the original state, and in the process I have filled my output array. That's the only logic, or that's the intention of this method. So I'm giving input, I'm giving him output, so output should be filled by execution of this logic. So why did we take this much of efforts to do it in recursion? Because recursion is a very important concept, and you all should start thinking in recursive terminologies, because the coming sessions in trees, graphs and all, recursion is the only way you can solve few problems. So that's the reason why we did it. So if you don't want to use recursion, you have to use stacks, and maintaining stacks and all will be a very difficult process. Okay, so I'm just giving you these two logics so that you can go through it later. Okay, now the next question, delete middle element from the stack. So how do you delete the middle element from the stack? So there is a stack given to you, one, sorry, input. So 1, 2, 3, 4. You will have to perform some logic in such a way that my input, the middle value is removed. What is the middle value? That's a 5. Middle value is 3. So 3 should be removed. 1, 2, 3 is gone. 4 and 5. If there are two middle values, let's say 1, 2, 3, 4, 5, 6. So there are two, right? So just remove 3. So this should come like this. 1, 2, 4, 5, 6. Okay, so this is the question, deleting middle element from the stack. How will you do it? So stack, just remember that there are only 3 operations allowed: push, pop, peek, and you can get the size, or you can just check whether the stack is empty or not. Find the length by 2 will get the middle. Okay, so after that I am interested in removing the middle. Can we use a continuous? Okay, you guys are not getting the question itself. So you are given a stack. So what is the use of continuous statement here? That just it. Just void. You need not to return anything. Just delete it in place, and then you're given a int stack. So how do you do this thing? And deleting middle element after. So I'll just do it in place, and then it is again stack dot toString. That's it. What is the command? Okay, solution. Okay, see 1 2 3 4 5, deleting middle element 3 4 5, but instead it should be 1 2 4 5. That should be the output, and you are only given this method to change. How will you do it? That means you are not given the access of this thing, you are just given this thing. So first of all, for those who are trying to do it in according to the length, so how will you get the length of the string, length of the stack? So you only get the, let's say that stack is only giving you four methods: push, pop, peek, and empty. Okay, that's the only thing. So how will you first of all get the length of the stack, and then how will you delete the middle get the middle, and how will you delete the middle? You can store in there and push all the elements except one. Yeah. So you can do it in these ways, guys. So first thing, why am I at the bottom? Okay. So the first thing is that you don't know the size of the stack, first of all. So you cannot create an array. First question, first correction. So if the array is 1, 2, 3, 4, 5, you don't know the size of the stack and you cannot create an array. So basically what you have to do, you have to just pop all the elements, put it in some queue or something like that, 5, 4, 3, 2, 1. And while this way, when you are popping all the elements, you can just maintain the count as well. Okay, then again you have to push them back. So if you push them back, this becomes a reverse array. So we will not use queue, instead we will use a stack. Let's say yeah, stack 5 4 3 2 1. So if we push all these things, so we get the count, and then we push all this thing back. So while pushing all this thing back, we can just avoid pushing the middle value. So how do we get the middle value? We can just we know the length, and then we can just do length by 2 will get us the middle value, and we can just skip that thing. So that is one approach. So the simple thing is we can maintain a temporary stack, integer temp is equal to new stack, int count is equal to 0, and now while stack is, I'll just check whether the stack is empty or not. Return. While my stack is not empty, temp dot push stack dot pop. Okay, This is done, and then I'll increment the count plus plus. Yeah, so now I have to do the middle value. So now again, while my this thing is not there, so this while my temp is not empty, I have to push it in stack. Stack dot push temp dot pop. So in this case, I just have to do it with indexes. So int index is equal to 0. So if my index is equal to count by 2. Okay, in this case, this is a middle value. So I can just say that skip this thing. So I'll just say continue. Yeah. So index plus plus I should have to give. So, okay, let's try to see whether this will work or not. So if the count is 1, that means the first element. 1 by 2 is 0.5. Index will be 0. Yeah, so this is the middle value. Let's say count is 6. So 6 by 2 is 3. So it should work. Let's see this thing. So 3 is not gone. I got push. Deleting middle element. Y index plus plus. Because we have to increment the index, right? So index means the element that is getting inserted. So first element will be getting inserted, then second, then third. That's why index plus plus. Let's go do the mid. Mid. Mid is 3. Okay. So now let's start with 1. So why is it not working? I'll just trace down the index value. So index 0, 1, 2, 3. So this should be skipped. So this continue. Oh, okay. So it should not be continue. It should be just temp.pop. So we just pop it and just remove it, because if we don't pop it, the next time we insert it will be the same. So yeah, so now it should work. See this. So now, okay, even now it's not working. Yeah, it is working. 4 is getting removed. So fine. For that we will fix it, but let's see whether 3 is getting removed in this case or not. Yeah, 3 is getting removed perfectly. So 6. Now I have to just see what is the case. So in this case, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So in this case, this is the middle value, right? So we told that we have to remove 3. So let's fix that thing. So now 4 is getting removed. So what can we do here is, so 0. Let's see, right? So we are having this 0, 1, 2, 3. So I have to remove this thing. So if my count is equal to 1, again depending on even or odd, we have to decide the middle value. So if not, we can just start with 1 and just see. So now 3 is gone, but it's a fifth case. I don't know whether 3 will be gone or 2 will be gone. Yeah, 2 is getting lost. So basically I have to do something like this, guys. So if my count is equal to count by 2 is equal to 0, that means it is an even case. So in this even case, my index should start from 0. Else, if it is an odd case, my index should start from 1. And then int index. So this should work for both the cases. So now 1, 2, 3, 3 should be gone. So 3 is gone. Even here 3 is gone. Yeah. So see, so now both the cases are working. I'll just remove this bloatware. So see, we're deleting middle element. So middle element was 3 according to our requirement. It is 3, so we have removed 3. At the same time, if the middle element is 5, so the input case of 5, the 3 is gone. Let's give him some corner case. So 1 and 1. Yeah, so 1 is removed. And then 2 and 1, 2. So 1 should be removed here again. Yeah, 3 and then 3, 2 should be removed. Yeah, so working fine. So this way we can do it. But first of all, did you get this approach? How we are maintaining count and all those stuff? Okay, so now the question is that you have to do it in recursion. So if you see, we are just maintaining a temp. So temp means we are storing something in the stack. So we can use the same thing using call stack. So I now want you to think in recursive terms. How do you do this entire logic in recursion? Using recursion, when we pop, we increment the count and then the recursive call, then during push, if the count is a middle, then we'll not push. Okay, something like that only. So if you see, if this is a stack, uh, I'm maintaining in this order. So 1, 2, 3, 4, 5. If this is a stack, right? So first I'm at 1, then I'll go to 2, then I'll go to 3, then I'll go to 4, then I'll go to 5. Okay, and when I'm returning back, somehow I have to maintain the indexes as well. So middle element is what? That means the distance from this to this thing and this to this thing should be same. So while I'm coming back, this is the first element that I'm visiting. Then 2, then 3, okay, then 4, then 5. So if you see wherever my indexes is matching from back and then from front, this is the middle value. So now for the odd case scenario, even case scenario, it will be a little different. 1, 2, 3, 4, 5, 6. Okay, so from back, this is the first element, then second element, then third element, then fourth element. So you have to maintain this condition where 3 should be equal to 3 or 3 should be equal to 4. So if we just write the logic in this way, then we can delete the middle element using recursion. So I will just write that logic. Let's clear up a bit. Okay, so this is my original iterative approach. Now I want a different approach. 2, I would say. So in this, as I'm doing recursion, the first thing that I need is what is the current index value, and then the second thing is what is the uh, reverse thing. So in this case, I have to maintain two things. So again, I will write a helper method. So public static int. So int will return the, so whenever I'm returning, see if you see 1, it is getting incremented to 2 and all this stuff. And then logic for delete middle. So first of all, I give him a stack because this is very important. So stack is given to him, and then I'll give him the current position. Okay. So now first thing first, if my stack is empty. So whenever my stack is empty, this is the case. Okay. So whenever he's here, so in this case, he has to return what? He has to return 1. So I'll just say return 1. If not, position, or I will say index last position is equal to logic for delete. I'm popping. Okay, first of all, I have to pop the value. Int value is equal to stack dot pop. Okay. Logic from middle. Now I'm going into recursion. So I've taken this one, I'm going into recursion. Taken this two, going to recursion, and so on. So internally, I'm maintaining my value in the recursive stack, call stack. So I will say stack, and then I will say current position plus 1. Okay. So if my current position is equal to last position, okay, this is the case. So 3 comma 3. If this is matching, or if this is matching, so if my current position, if my current position is equal to last position minus 1, okay, in both the cases, this case and this case, I have to skip it. So I just have to skip, and then else I'm just skipping it like that. Else I have to push the value, stack dot push value. That's it. And when I'm returning, I have to return last position plus 1. Last position plus 1. So if you see, this is there, it is 1. So now when I'm returning from this position, it should be 1 plus 1, 2, and so on. So this thing, if I just do delete position, take the stack and start from 1, so it should recursively solve the problem. Let's say 2. Let's see if it works or not. Last position. See, 3 is gone. 1, 2, 3, 4, 5. Similarly, if it is having 6 elements, 3 should be gone. Okay, 4 is going. 4 is going. So it should be how much? So current position minus 1 is equal to last position. This should be the case. Yeah, this is the case. One, two, three. Okay, so I am doing it in reverse. So if I pop the values, it will be 5, 4, 3, 2, 1. Okay, and that's why we got this mistake. So if I just take a stack like this and I start popping, it will not start from 1, it should be starting from 5. And that's why there was this mistake. So it should be current position minus 1 is equal to last position. Okay, see, now 3 is gone. Now if I give him a 5, so now 5, 3 will be gone again. So see this, the middle element 3 is gone. So if I give him a single element, single element should be gone, and everything is remaining the same. Okay, so this is the part, guys. So this is a recursive solution. So I am just checking the current position with the position from the back, and based on that I am just skipping the value. How do I skip? If both of them matches or there is a difference between them. So this is the one. Current position minus 1 is equal to last position. If this is the one, then I have to delete it. Did you get this recursive solution? And I'm starting from 1. If you see, the current position starts from 1, And at the very last also, when stack is empty, I'm returning 1. Come on guys, let me know in the chat, did you get this solution or not? So which part did you not understand? Even put that in the message if you're not understanding. So the last position is, let me explain you one more time. So if my stack is like this, 1, 2, 3, 4, 5, we say that we have to delete 3. So when I start my popping operation, 5 will be popped first, then 4 will be popped, then 3 will be popped, then 2, and then 1. This is the popping of order. If you see position wise, this is the first position, second position, third position, fourth position, fifth position in the array, in the stack. Okay, so I have to delete 3. So when I go to null, I am returning 1. So this is nothing but, this is the position from the back. So this is the position from the back. So 1 and this 2 is the position from the back, 3 is the position from the back. So this is the part where these two matches. So the back position or the current position or the position from the last index. So whenever these two matches, that means this is the middle element. I have to skip it. So that's why I'm skipping it. I'm not pushing it in the stack, if you see. Okay, and then again I will continue and push all the elements. So first of all, I'm popping all the elements, and then I'm pushing all the elements. This you have already seen in the reverse strategy. uh, where is it? This one, this you have already seen here, the same thing, but before pushing I'm just checking what is the condition. Similarly, if the array is something like this, let's say 6. Okay, in this case there will be one more element here, 6. Okay, so let me write. Yeah, so 6 will be popped, then 5 will be popped, then 4 will be popped, then 3, then 2, then 1. Okay, so index wise, this is the current, these are the indexes. That means the positions. And when I'm coming back, this is the last position, second last, third last, fourth last, fifth last, sixth last. According to our exam definition, we said that you have to remove 3. So removing 3 is nothing but whenever 4 and 3 matches. So 4 is what? Current index. So current index minus 1 is equal to last index. Okay. Current position or last position. I have named the variables like that. Okay. So whenever this matches or this matches, I have to skip it. If not, I have to push it. Okay. So this is a recursive solution. You have to think in recursive sense. Try to understand what is going into recursive call and what is coming out of recursive call. Only then you will understand the solution. Okay, so fine then. Okay, guys. So with this, I think we can close this today's session. So we have seen few problem statements. In tomorrow's problem, in tomorrow's or not tomorrow's, when the next session we will discuss about queues. Okay. So did everyone follow today's session? So guys, from now start thinking in terms of recursion, because trees, stack, graphs, and all, you have to think in recursively. So if you are not comfortable in recursion, start practicing recursion from now. So there is only one logic, or there is only one thing to remember in recursion. That is the main base thing. What is the end condition? Okay, when does my recursion stop? Second important thing is what is going into recursion. Third important thing is what is coming out of recursion. So these 3 important lines, if you understand, then recursion is very simple. So if you see, this is the part where I will stop, and this is the part that is happening while going into recursion, and this entire part is happening while coming out from recursion. Okay, so understand in this sense and create your logic accordingly. So just understand these 3 points and create a recursive logics. Okay. So I think we are good. We can finish the session. I hope you all liked it. So what is the next? When is the next class? Monday. Monday we will talk about queues. Okay. So till then, try practicing stacks, queues, linked list problem. Linked list, practice linked list problems as much as you can, because linked list is a very important topic, and you might expect competitive questions on linked list in from many of the website, many of the companies. So most companies ask you questions on linked list, arrays, strings, trees. Graphs, no one asks them, but these are the 3 things that they generally ask: arrays, linked list, trees. So in this 3 topic, you have to use your stacks, queues, and all those other data structures to properly get the answer. Okay then, guys, let's close the session. Thanks for joining. Have a good day.